I would like to create a new folder in order to get the topography and roughness map for this case study. To do that, I have created one new folder for train model, named train model. For train model, I'm going to get two files. First of all, for topography or digital elevation model, and the second one for the roughness. For the topography, I have selected this object, elevation grid data, drag and drop here. Now I would like to access the online database. I would like to emphasize that we can use this object in order to get different types of elevation data like DTM, digital terrain model, digital surface model. Click add layer from online data, and then we have this window to get the data for all parts of Germany. You can access the local database here. I can get the elevation data from Thuringia state with in different spatial resolution, 5 meter, 10 meter, 20 meter, and also you can get the SREM database or other online database. But for this case study, I would like to access the local data, the boundary 20 kilometer by 20 kilometer. It's good enough for our case study. This is the DTM model, special resolution 20 meter by 20 meter. Sometimes you can select 5 meter, but it's good enough. You can export. There's a possibility to export this layer to another format, to contour lines or surface data, or to different format. Click OK. Yes, this is for vast sweating, to detail vast sweating. Okay, now this digital elevation model successfully loaded here to your working background maps. Now for all wind turbines, I have also the elevation value here. Here you can get the elevation model, and I can change the color transparency here, but there's still digital elevation model stock to model. Doesn't matter when you are changing the color setting or different setting, you will still have digital elevation model. I would like to get this 12 color setting. It's better from my point of view, and then turn on legend. And this is the raster layer for digital elevation model. It's not actually the contour data, it's the raster layer. So because we have already imported the grid elevation. Okay, now I would like to create another layer named 3D map, because I would like to use one functionality of this 3D map. For this purpose, please create a shape, because we are going to see this 3D map inside this shape. Rectangle. This is the approximate dimension of this rectangle, and I would like to see the 3D visualization inside this rectangle. Okay, and go to select this object, go to geodata, and click 3D map. There we go. We have now 3D map view of our case study. And at the left hand side, you see also the detail setting for this 3D visualization. First of all, I would like to reduce the vertical exaggeration because it's over exaggerated, because our site is not so complex that you have already seen, and you can click, you can pan, you can move this visual or rotate it, or you can turn on auto spin, and also you can turn on show surface grid. Okay, so this is a good representation when you would like to compare different wind turbines elevation across your wind farm. Beside this, I would like to show you 2D profile. So click, select this object rectangle, and then click train profile. So this is 2D profile. We have already seen 3D profile, but this is 2D profile. So you see we have already created two layers, WTG commission, WTG planning, both layer included. So click render, then it takes a little bit. So it depends to your topography. So now our 2D profile loaded. So both WTG commission and WTG in planning both included. So you can also change the layer marker setup. So click layer marker setup, and then first of all for WTG commission, please apply this setting, exactly this setting. So click apply. You see WTG commissioned as a marker added here. For the next step, goes to WTG in planning, and then apply the same setting for WTG in planning. Okay, there we go. So you see the marker setting for two layers added here, WTG commission and WTG in planning, and you can see the elevation for both parks, which are already commissioned, and WTG in the planning. There we can distinguish between the both wind parks WTG commission. You can save this layer if you would like to save it, for example, to JPEG format or whatever you'd like. Okay, to show you another feature of this software. So this time we would like to see a quick profile. So first of all, create a new layer. So rename it this layer to insert ruler. Okay, there we go. Now find the related object, insert it on your working background map, create a ruler. So the dimension is approximately 3 kilometers. Go to definition tab and click quick profile. So this is a quick profile. So it means we have a quick profile to see the elevation variations alongside each direction. If you click view legend, you can see slope. We can also change the setting font legends. So 5 lines, click auto values and auto colors. So we have a wider range of slopes. So there is a possibility to see the terrain variations alongside each side. So you can move this ruler alongside each side, see the terrain, the elevation variations alongside each side. The direction of this terrain profile is from west to east. And you see now I would like to create another ruler, this time a vertical ruler, the direction. You would like to see the terrain elevation from south to north. So right click, click properties. And then we have the setting for this ruler, length, and also angle. Make sure that it's 0 degree. And once again, when you are moving this ruler alongside this direction, you can see the different setting. So this is from south to north. This is the purpose of this exercise. Is I will say that it's a practical feature. When you would like to plan a wind farm, you can see the vertical and the horizontal variations across your wind farm. Okay, so sometimes you can also save this quick profile. So right click on this picture and then copy, or you can directly copy to clipboard. So to use in your presentation. So now the next purpose is to create another layer. We would like to load the shapefile of district Nordhausen using WTG area. So first of all, insert this WTG area object into working background maps. Now upload your new file, your shapefile. So this shapefile is used to load district Nordhausen. So load, first of all, we need to assign the right coordinate system, which is appropriate to this file, UTM 89. And then this is a setting to import a shapefile. Click OK. There we go. Click OK. So now the shapefile for this area successfully imported. This is district Nordhausen. So I wanted to show you how you can use WTG area to import different shapefiles if you would like. And if you right click here, you see here area information for this area. And so right click and then click show legends. You can see also the legend. If there is several areas, then you can see the legend here. Okay, for example, for different areas. And then now I would like to load a layer. So go to result layer, right click, and then browse this wind resource file, which already calculated by me. Just browse this RSF file. This is the output of wind flow simulation. Click select. So this new file added into result layer window. So first of all, select coordinate system. So UTM for all layers. Our coordinate system is UTM north, ETRS 89, zone 32. Okay, now the wind resource file loaded here. So you see this 100% match to our shape layer, which already imported our district Nordhausen. You can also change the color setting if you would like, turn on legend. This layer is used to wind speed, mean wind speed at height 28 meters. So we have several heights, for example, 140 meters, because this wind resource file already calculated versus different heights above ground level. So for example, 170 meter for wind speed. So 140 meters is good because we have Nordex wind turbine, which hop height is 140. So we have also more layers here inside this layer. For example, a specific wind energy, watt per square meter. This is the power density of available wind energy. You see the legend change. And so while you are moving the cursor, you can find out the value at cursor. At the window, you see now the value is changing at cursor here 6.97. Okay, you see here value at cursor, and this is wind speed at height 140 meter. You see here's 6.11. So wind speed changing across wind farm. This is the horizontal extrapolation of wind speed across your wind farm. For new wind farm also it's a little bit lower for the wind farm which is under construction. With the resolution, you see better view of this wind resource map. You're able to see the windows, so right click and then click show rows. So you are able to see windows or energy rows directly in your working background map. So here, so turn on this checkbox. For example, a specific wind energy watt per square meter. You see, now we have wind rows at cursor, so 290. We have wind rows and as well as the value show at cursor position, and then we have power density or wind frequency rows at each position of this wind resource file. We have now two wind rows, so mean wind speed and power density. So this was another feature. You can also right click and then export to your favorite layers like GOT format or surface grid format to use in your presentation, in your work. There we go. Okay, there we go. Now I would like to add another layer. So to import the roughness area, so rename it this layer to roughness area. And now select the related area object, insert it into working background map. Select the purpose of the data. So I would like to roughness map. Then click online data because we would like to use the online database. So windPRO software, click online data. For roughness area, we have different kinds of database. So select the first one, Korean land cover 2018, and this is the boundary. So keep the default values and then select OK. So now the data, roughness area data, successfully imported. We have, you see, we have different roughness class and roughness length for different land surface characteristics. Assigned the roughness value for background map 1.5, and then you see we have different land surface characteristics versus different roughness class, and then go to import export, click export to export it to roughness control line. So save it. So it takes a little bit. Click yes here to create a new control line object. The new object created. Now click OK. Okay, as expected now, we have both roughness area and roughness contour lines into working background maps for right click and exit from edit mode. What does roughness contour line mean? It means when you keep your mouse for a second there, you see the roughness class outside and inside of this roughness contour line. For example, here outside is 1.5, which is the roughness length, roughness class for background, and inside would be roughness class, for example, for this forest or for this city area. So sometimes you can import directly this roughness map. So go to result layer, right click, select import. From import, you can browse your roughness file. Here we have already generated this file, WPO file for roughness. So import, and then you can import all files. Click OK. So the roughness map is being imported inside the result layers. If you right click there, you can import there. OK. The new roughness map imported successfully there. So it takes a little bit to be loaded into working background maps. We have to wait. Okay, now it's loaded. This is exactly the roughness map based on the event data that we have already imported from Korean land cover, the online database. If you click here, once again, you can change the color setting different, for example, 12 color scales to see a better view if you would like. Or I'll also turn on the legend. So this is the roughness length for different land surface characteristic. So the lowest value is 0 and the highest is 0.7 meters. I can turn off this layer, disappear this layer. There we go.